Hi, today's video we will discuss units and dimensional analysis. Back in 1960, an international agreement was made to adopt a uniform system of measurement to be used by the scientific community. The system is called the SI system. A measurement must always contain a unit. So the SI preferred units, for example, the mass is measured in kilograms. And a kilogram has an abbreviation kg. Length is measured in meters, and we use a lowercase m. Time is measured in seconds. We use a lowercase s. Temperature can be measured in Kelvin. This would be an uppercase K. And the amount of a substance is measured in moles, and we use MOL. Derived units. Derived units are units that are calculated. For example, area. Area is length times width, and so the units will be meters squared. Volume, length times width times height or depth, will be meters cubed. Density. Sometimes you'll see rho or a capital D for density. So this will be mass divided by volume. So this will be kilograms per meter cubed. Speed. This will be distance divided by time. So it would be something like meters per second. Energy. Energies can be measured in joules. And a joule is 1 kilogram meter squared over second squared. Pressure. We measure in pascals. Now, Pascal is 1 kilogram over meters second squared. All right. Some fundamental constants you need to memorize or store them somewhere so you can easily retrieve those. Be like the mass of an electron. Well, the mass of an electron, we're going to be using 9.11 times 10 to the negative 31st kilograms. The charge of an electron. (1.6 times 10 to the negative 19 coulombs. Avogadro's number. (6.02 times 10 to the 23rd. Planck's constant. 6.626 times 10 to the negative 34th. This would be joule seconds. The speed of light. At 2.9979 times 10 to the 8th meters per second. Most people will say 3 times 10 to the 8th. Ideal gas constants. .0821. That will be atmospheres, liters over Kelvin mole. Or if I'm dealing with energy, 8.314 joules per Kelvin mole. All right, some useful prefixes. I think you should probably learn from mega down to possibly nano. So mega would be a capital M, and it is 10 to the 6 power units, wherever the base unit is. Kilo would be a lowercase k, and that'd be 10 to the 3rd units. Deca, or DA, is 10 to the 1st. Then you have your base unit. Then deci. Deci is a lowercase d, 10 to the negative 1st. Centi, lowercase c, is 10 to the negative 2. Milli, lowercase m, is 10 to the negative 3rd. Okay, I'm going to put the next one here. Micro, which is the Greek letter mu, which is 10 to the negative 6. And nano, lowercase n, 10 to the negative 9. These are the ones that you probably should know for general chemistry. Sometimes you'll see an angstrom in our problem. This is not a SI unit, but it's often used to express the size of an atom, size of a molecule, the length of a chemical bond, or whatever. And the angstrom is 10 to the negative 10 meters. You see that a lot. So I thought I'd include that one also. Okay, so let's try some simple temperature conversions. Like if I want to go from degrees Fahrenheit to degrees Celsius, the way I would do it is to say my degrees Fahrenheit minus 32 times 5/9, or I could say degrees Fahrenheit minus 32 divided by 1.8. So an example here would be like if I have, let's say, 85 degrees Fahrenheit. If I were to subtract 32 from this, and let's say divide by 1.8, it would give me 29.4 degrees Celsius. If I was going to convert Celsius to Fahrenheit, I would do basically the opposite. I would take my degrees Celsius times 9/5, or 1.8, and then add 32, and that would give me the Fahrenheit temperature. For example, 37 degrees Celsius times 9/5 plus 32, that would give me 98.6 degrees Fahrenheit. And to convert from Celsius to Kelvin, or from Kelvin to Celsius, you simply either adding or subtracting 273.15. So if I'm going from Celsius to Kelvin, I simply add 273.15 to get Kelvin. And if I've given Kelvin, I want to go to Celsius, I'll take Kelvin and subtract 273.15. So if I have something like 64 millimeters, and I want to convert it to meters, the way I would do it, if I'm going to meters, is I would say 64 millimeters times a fraction. This fraction must equal 1. And I want millimeters to cancel, so millimeters have to go on the bottom and meters have to go on top. I instruct my students to put a 1 with the unit that's the largest. Well, meter is a base unit. It's 10 to the 0. Millimeter is 10 to the negative 3. I will say 10 raised to a power of the difference between the base unit and the millimeter here. So if this is 10 to the 0 and this is 10 to the negative 3, there's 3 powers of 10 difference. So I'm going to put a positive 3 here, like that. So therefore, I would get, when I do the math, I would get 0.064 meters. Okay, let's do a couple more. If I have 0.025 kilometers, I will convert this into centimeters. Well, I would say 0.025 kilometers. I want kilometers to cancel, so if it's on top, I put it on the bottom. What I'm looking for goes on top. I put a 1, which is with the largest one. Kilometers larger. Remember, kilometer is 10 to the positive 3. Centi is 10 to the negative 2, so there's 5 powers of 10 between those. So the kilometers cancel. My final answer will be 2,500 centimeters. Let's try something like 48.8 micrograms, and I'll convert it to, let's say, milligrams. So I would start with the 48.8 milligrams. I'll put milligrams on bottom. What I'm looking for goes on top. Okay, milli is 10 to the negative 3. Micro is 10 to the negative 6. So milligrams are larger. There's 3 powers of 10 between those, so I'll put that there. So I'll say 48.8 times 10 to the third. So that's going to give me 4.88 times 10 to the fourth power micrograms. Okay, let's try one more. 125 nanometers to centimeters. So I'll say 125 nanometer. I have nanometers on top. I put nanometers on bottom. And centimeter goes on top. Nano is 10 to the negative 9. Centi is 10 to the negative 2. So centi is larger. There's 7 powers between the two. So I'll say times 10 to the 7th. So I'm going to enter this into my calculator. I should get 1.25 times 10 to the negative 5 centimeters. Okay, let's try something a little more difficult here. Suppose I have 2,500 square centimeters. Now I want to convert this into square meters. All right, this is a little bit more difficult. So we have 2,500 centimeters square. I want centimeters square on the bottom. I want meters square on top. Again, this is 10 to the 0. This is 10 to the negative 2. So this is larger. The meter squared is larger. So there's 2 powers of 10 between these two. But since I'm squaring it, I need to square this like that. So essentially what I have is 2,500 centimeters squared times 1 over 10 to the 4th power. All right, so this is meters squared, centimeters squared cancels, like this. So my answer should be 0.25 square meters. Okay, so let's try some dimensional analysis or multi-step conversions. So I've given you that we have 2.5 times 10 to the 4th seconds. I'll convert this into days. Okay, I need to multiply this times a fraction equal to 1. I know that 1 hour is 3,600 seconds. Seconds cancel. I know that 1 day is 24 hours. So hours cancel. So if I would say 2.5 times 10 to the 4th divided by 3,600 times 24, it will give me my answer in days. Okay, so you plug this in your calculator, you should get 0.2894 days. Okay, how many liters are in 1 cubic meter? Okay, now I know that 1 liter is 1 cubic decimeter. All right, so I need to start with 1 meter cubed. Meter cubed goes on bottom, and decimeters goes on top. Okay, so I know that this is 10 to the 1st power raised to the 3rd power, because I'm making this conversion 3 times. So therefore, meters cubes cancel. 1 times 10 to the 3rd power, or 1 times 1,000. So my answer is equal to 1,000 cubic decimeters, or is 1,000 liters. And I could show that by adding another step here, where I would say 1 liter is equal to 1 decimeter cubed. So decimeter cubes cancels, and that gives me this answer. If a radio wave travels at 3 times 10 to the 8 meters per second, how long will it take to travel a distance of 1.5 times 10 to the 6 kilometers? So we need to start here. So I'm going to say 1.5 times 10 to the 6 kilometers. All right, since this is meters here, and this is kilometers, so I need to convert to meters. So kilometers goes on bottom, meters go on top. 1 kilometer is 1,000 meters. Okay, so I need time. So 1 second over 3 times 10 to the 8th meters. Meters cancel. So in my calculator, if I would say 1.5 times 10 to the 6th times 10 to the 3rd divided by 3 times 10 to the 8th, that should give me 5 seconds. All right, the world record for the long jump is 29 feet, 4 1/4 inches. Convert this distance to meters using 1 inch equals 2.54 centimeters. All right, so I need to start here. This is my given. So I have 29 feet plus 4.25 over 12. All of this will be my feet. I know that 1 foot is 12 inches. Feet cancel. I know that I have inches on top. I need to put inches on bottom. 1 inch is 2.54 centimeters. Inches cancel. Now convert that into meters. So 1 meter and centimeters go on the bottom, so that'll be 100 centimeters, which is 10 to the second power. So now when I do the math in my calculator, you should get 8.95 meters. Okay, thank you for watching.